on Iceberg was to support user data deletions. And that was the first use case of guinea pig at Pinterest, which proved that like, Iceberg can solve problems at Pinterest. And then from there, we just scaled up. And today, we'll be talking about those new use cases that we have. We are solving with Iceberg at Pinterest. Right. So the media engagement part of this presentation is going to be adoption and use cases. Today, we have around 6,000 tables at Iceberg. And in these 6,000 tables, there are around 150 petabytes of data. And when we look at the growth of Iceberg at Pinterest, we roughly see around 25% year-over-year growth in number of tables and 22% year-over-year growth in data volume. And this is like data that has been brought from, say, like migrated from high tables, and also includes the data that like we have organically increased over the year. In terms of user-facing services, we support Iceberg as of today from multiple places for our users. Trino is very commonly used to read the Iceberg data. Spark, on the other side, is a much more mature engine that we provide integration with Iceberg. It enables users to do read and write. Also, there are like a bunch of procedures that comes with Iceberg, and then we have custom built a lot of procedures at Pinterest to suit our particular users' use cases. On Flink, it's mostly the write support that we allow users, and one of the few of the use cases that we'll talk about today is from Flink. We also allow our users to read Iceberg metadata, take a lot of actions like waiting on data to be ready, checking on data quality, publishing metadata, all that from Python library. And then we do have a lot of MapReduce footprint at Pinterest, but we have a custom framework built on top of MapReduce, which we call a sanitizer. So we support writes from that custom. That's the only place that we allow MapReduce to talk to Iceberg. And then starting last year, we have our users are using machine learning platform. Users are using Ray, and we provide that support using Python. And then we also have custom integrations to do things like bucket joins and stuff. Okay, so now let's talk about like a particular use cases. So this was one of our first use case at Pinterest, user data deletion. Prior to Iceberg, what we used to do is that we would rewrite the entire table to delete a few users. Now you can imagine like that used to take a lot of time. It was super expensive. Every time there was an incident, backfill used to take a lot of time. Everyone was worried that, oh my God, like the backfill is going to fail, and then that will increase the incident resolution time. Iceberg helped us resolve all of those issues using copy and write. So we just read the files from S3 that contains the rows or the user that needs to be deleted. We exclude that and just rewrite those files, right? And what we did, and again, like if the number of files that you're rewriting with all the files in the table, you are same as rewriting the whole table. So for that, like we introduced a lot of improvements and optimizations with which we were able to scale from 20 data sets that we were able to do user data deletion on to 150 data sets today, while reducing 30% of the storage footprint and 30% processing cost. And it used to take like a few weeks to do the data deletion, but now we were able to do in a few days. Also, like reduced our job failure rate by 90%. One of the key things that we did here was we made sure that all the data is sorted and bucketed by the user ID on which we want to do the deletions on. And we had to make some nuanced optimizations. For example, if we are running a delete operation, we don't want to sort the data again.
Yeah.
What's the race?
Yeah. So because like we sort the data once when the data is written, after performing the deletion, we don't want to sort the data again, as long as we are maintaining the order. Because we all know like sorting is super expensive. We kind of introduce mechanisms where we would look at the file that's involved in the deletion, and we'll see if the sort order of the file is the same as the order of the table. We'll skip that file from getting participating in the sorting again, and that tremendously reduces the cost of our deletion processes. Okay, moving on to the next use case. A lot of like analytical productivity is tied to how frequently we allow our analysts to run their queries, right? To do so, we really wanted a mechanism for our analysts to be able to build their query using partial data, and then we are sure their logic is correct, and they can scale it up to the full data size. To do so, we introduced table sampling, not a new concept, but very common in the industry. Before Iceberg, what we used to do is we'll take an existing incoming Kafka stream, and then we will have 1% of that stream go into a separate table as well. And that separate table would form the basis of the sample data that users used to use. Now, the problem with that is, first, it's not a deterministic way of building the sampling. For example, you have two tables, right? And you're doing a join. Now, if you're doing a join, there's no guarantee that like there will be any match in the join, because like you're just doing 1% of the data. Say like two streams are coming in, one skipped user X completely, the other one has user X. So you will miss the information on user X completely. Solve that problem, what we did is like we utilized, and also there's the cost of like storing 1% of data twice. With Iceberg, what we do now is we bucket the data. So far, I'm just taking user ID as an example, could be on any column. We will bucket the data, the Iceberg table on user ID. And when a user says that, oh, I want to run this query on 1% of data, right? Say like we have 100 buckets of for user ID. We'll just need one bucket. So that's like our way of doing, okay, 1% of data is being read. Now, the good thing about this approach is that if you have two tables bucketed by user ID, and as long as you are doing reading 1% of data from both the tables, you are guaranteed that you are going to hit the same users in both the tables, because both the tables are bucketed by user ID. So with that, like we not only allow users to first run very quick prototypes, but we also allow them to be able to do the joins, reasonable joins. And to make this happen, like table sampling is a kind of function that most of the engines provide. But we made contributions to Trino, and Spark already had it. We just had to make some optimizations there to make sure that when table sampling is called on Iceberg table, it uses and if the table is bucketed, it takes advantage of that. So with that, we were able to, like our users saw improvements like without table sampling query that would take 4 or 5 seconds, we'll finish in just 12 seconds. Nothing out of the world, like that's what the table sampling is meant for. But the big benefit was that this was reproducible. So, and it also represented correlated very closely with the full data set queries. In some of our production data sets, we saw that the correlation of queries, sample queries, was within 0.5% deviation. So this gives a lot of confidence for our users to be able to use sampling for their prototypes. All right. The next use case we have is near real-time ingestion. And prior to Iceberg, we used to use Spark streaming, right, to hide tables. But with Iceberg, now and we also have Flink. So we are doing from Kafka, we read and process through Flink and then write to Iceberg tables directly and in micro batches. And the reason Iceberg is helpful here is because you can have background processes that like do the compaction of the files, or if needed, like you rewrite all the files and the metadata. And this is very helpful because in Spark streaming, like if we or in the Hive world, if we were to do this, we'll have to wait. We'll have to wait that the readers are done reading before we can rewrite the partitions. So this tremendously improved our backfill capability and also the incident resolution time. And upcoming, not upcoming, we already have it in production, but then it's becoming more and more popular is the CDC use case, change data capture use cases using Iceberg. Using Iceberg, we are able to provide near real-time mirroring of online databases like MySQL, Tidy, KVStir, and all of them like follow the standard pipeline. Like all of these DBs provide a CDC stream, which we stream to Kafka, and from there Flink reads it, and then write in micro batches to Iceberg CDC table. And then we use Spark 3.5's merge into capabilities to then eventually merge into the main Iceberg table. And then like bucket joins, and I touched upon this bucketing quite a bit, and we use that for sampling, but we also use that for efficient joins. And we have bucket joins is not a new concept, like it's a very standard practice. But with the storage partition joins, also referred as bucket joins, we are able to make it easy for our users to adopt bucket joins. And with that, we have seen some of the very large use cases at Pinterest see up to 65%, just because like they can remove the shuffles completely, which tends to be very expensive. However, we are working on a few challenges around it, which is supporting bucket join on tables with a different number of buckets. We solved this and contributed back to Trino. Not sure if the PR is merged though. And then the other challenge that we're working on is how to determine like what is the appropriate bucket count based on the size of the data, and also like how to allow users to update the bucket count and still be able to support bucket joins as the data volume grows. Data quality checks is another use case where we utilize write audit publish. It's adopted by several teams, but that particular use case doesn't really suffice for our machine learning platform teams. It was initially machine learning platform teams, but now a lot more teams are asking for support where they don't want to roll back a snapshot. They want to roll back part of the snapshot. So say like when your snapshot wrote to like 5 different partitions. They want to roll back only one partition. So we custom built some procedures to support that. And it's actually becoming more popular than the complete snapshot rollbacks. All right, that is all the use cases that I wanted to share with you all. I'm sure like you have similar use cases, and I would be happy to talk to you guys about it. I guess we have time for questions.
Yeah, we'll have time for just a couple of questions. So.
We covered many use cases. In this case, we are looking at did you guys did a catalog implementation on iMetaStore as it? That's the first question. The follow-up question is, when you migrate a table from Hive table to the Iceberg, did you do rewrite the stacks or just to do like metadata migration from table level?
Yeah. So the first question was like, are we using any catalog? So far until last year, we were just using iMetaStore. But this year, we are going to productionize a REST catalog based on Gravitino project. So we are going live with that end of this month, which is tomorrow. The second question was.
So when you migrate a table.
Oh, yeah, migration, yeah. So it was in place or like we did the data migration. Because our data volume is so much, as I said, like it's around like half exabyte, to like data migration. So what we did was we did in-place migration. And because we were early on, we found a lot of challenges around it, where, for example, part A, two-level list, two-level maps were not supported. So we improved Iceberg partially to support that. But as of now, we are confident that we are able to support it. We have actually an auto migration service that enables our users to migrate the readers, writers, and the table, everything at the same time. So that's how we are able to scale up the adoption of Iceberg by building the tooling to do the migration. We always do the migration. We never migrate the thing.
Are you planning to open source the migrator tool?
We can, but like it's been custom built, so I'm not sure.
I think we have one.
I couldn't hear the answer to that. I'm sorry. I couldn't hear the answer. Can you hold the mic a little?
Oh, sorry. To which part?
The question about open sourcing.
So this is a very custom tooling at Pinterest that we use for like Spark upgrades, for like moving data from like text file format to Parquet file format. So it's very deeply rooted to Pinterest infrastructure. We have given multiple talks about, if you look online, auto migration service Pinterest, you'll find a bunch of talks that we have given. But this one too, like we have used for like automatically upgrading Spark versions, file formats, table formats. Yeah, I'm not sure like if there will be a lot of value other than what we have shared as presentations.
Yeah, thanks for the great talk. I had a question regarding one of the slides you had mentioned in user data deletion. That Spark job failure rate, there was 90% reduction. So what was causing the Spark job failures and what contributed to the significant reduction in the success of those jobs?
So just the fact, just the fact that the Spark jobs took weeks. The longer job wins, the higher probability of it failing, right? So we went down from weeks to days. That's one of the big factors. Second, the Spark job had to read and rewrite all the data. So imagine like if you're writing 1.5 petabytes of data versus like me rewriting like just a few, less than a petabyte of data, right? So that also, because like the scale is brought down significantly, the number of failures went down. The other fact with the Spark was that the way they were rewriting it, it involved a shuffle. And that shuffle was super expensive. With this one, like we made sure that we are not shuffling. We are using the bucketing bucket joins. If you are unable to use broadcast joins, then the bucket joins. And we made sure that like even while writing, we are not doing any sorting, we are not doing like any kind of shuffle aggregation, any such thing. So we made sure that it's very simple.
I think we'll have to take the question later. We have a break coming up after one more session. Thanks a lot to Ashish.